Guys, this is going to be our first video for our review of our last test about differential equations. So this one's going to do the first 8 questions. All right, so let's try number 1. For what value of k, if any, is this function they've given us for y a solution to the differential equation y minus y double prime over 4 equals 5 times e to the 4x power? So when I look at the differential equation, remember that it just has to include some function y and some derivative, second derivative, some order of derivative of that function. I notice I have the second derivative. So what I'm going to do first is I'm going to find the first derivative of this y function and then find the second derivative. All right, so I'm going to do y prime. All right, remember to do the derivative of these natural exponential functions. You're just going to copy it down. All right, so e to the negative 2x, and then you multiply by the derivative of that exponent. The derivative of negative 2x is negative 2. All right, same thing here. So e to the 4x, derivative of 4x is 4, so that's going to be 4k. Now, when I look at, again, my differential equation, I don't actually have y prime in there, but I do y double prime. So I'm going to do it again. So copy e to the negative 2x. Negative 2 times negative 2 is a positive 4. And then I have plus e to the 4x. Derivative of that again is 4 times 4k is 16k. All right, so now I'm going to essentially just plug in here and see if I get 5 times e to the 4x power. All right, so I have e to the negative 2x plus k times e to the 4x, right? That's my y, all right, minus y double prime, which is 4e to the negative 2x plus 16k times e to the 4x, all divided by 4. All right, now, at the end of the day, this is going to be equal to 5 times e to the 4x power. And I noticed that the last two terms are divided by 4, which they can divide by 4, so I'm going to go ahead and do that. So copy these down. All right, that becomes negative, the opposite of e to the negative 2x power, and then minus 4k e to the 4x power. All right, so now you'll notice that my 2 of my 4 terms are going to make 0, right? This e and this one is going to make 0. So now I have k e to the 4x power minus 4 times k times e to the 4x power equals 5 times e to the 4x power. And those are like terms there. So I would do k minus 4k, that's negative 3k. All right, and then e to the 4x is on both sides. So really this just becomes, an algebra question. What's going to make this true? K is equal to negative 5/3. All right, which is letter A. All right, so we practiced this in our first section on this unit on differential equations. All right, let's try number 2. Very similar type question. Again, when I look at my differential equation, it has y double prime. So I'm going to find y single prime, and then I'll be finding y double prime. So when I do the derivative of sine, I know that's going to be cosine, right? So cosine of my argument, but I need to use the chain rule, and the derivative of 5x is 5. So that becomes 5k in front. Then the next one, the derivative of cosine is negative sine. So we're going to write minus the sine of 4x. But chain rule, derivative of 4x is 4 times that 2 that was already there. Means that would be minus 8. Write it a little closer. Okay, now double prime. Same process. Derivative of cosine is going to be a negative sine. Derivative of 5x is 5, so that's going to be minus 25k. And derivative of sine is going to be positive cosine, but since it was a subtraction, it's got to stay subtraction. All right, derivative of 4x is 4. 4 times 8 is 32. So now I've got my double prime. All right, so let's go ahead and substitute right here. So negative 25k times the sine of 5x minus 32 times the cosine of 4x plus 16 times the original, which was k times the sine of 5x plus 2 times the cosine of 4x, and all of that has to be equal to negative 27 times the sine of 5x. All right, there's a lot going on here, but I think you'll see it just makes it seem more complicated because of the trig functions in there, but really it's just a lot of algebra here. So I'm going to copy these down. All right, so bring these down. Okay, I'm going to distribute the 16. So 16k times the sine of 5x, and then plus 32 times the cosine of 4x. All right, and you'll notice that kind of like in the first one, you've got two pieces that are going to make 0. This negative 32 cosine of 4x plus 32 times the cosine of 4x, that's going to make 0. To give us just negative 25k times the sine of 5x plus 16k times the sine of 5x equals negative 27 times the sine of 5x. So lots of like terms here. I'm going to subtract negative 20, or I guess add negative 25k plus 16k to get negative 9k. And once I do that, the sine of 5x are going to essentially go away, and I just have negative 9k equals negative 27. So k equals 3, which is C. All right, so that's it. Very similar type of question, just a little bit more confusing with finding derivatives of trig. Okay, number 3. It says, of the following, which are solutions to this differential equation? And you'll notice we have 3 options, right, in our answer choices, and we're going to determine if one of these, 2 of these, or all 3 of these are going to make this differential equation equal to 0. All right, so I'm going to start with the first one. All right, I notice in my differential equation I have the original function y, I have the single prime, so the first derivative, and I have the second derivative. So I need to do all 3 of these. So I have y prime. All right, derivative of sine is cosine. Don't forget the chain rule. Derivative of 3x is 3 times that original 2 gives you 6. Y double prime. Derivative of cosine is negative sine. Again, chain rule, derivative of 3x is 3 times 6 is negative 18. So I'm going to plug this in. I have negative 18 times the sine of 3x, that's the double prime, minus 10 times 6 times the cosine of 3x, right? That's the single prime, plus 9 times the original one, which is sine, 2 sine, my bad. 9 times 2 times the sine of 3x. Now, I could do more expanding here, but I think what you should notice is the signs are going to cross out, right? This term on the right side here, I'll highlight it. This term right here is going to make positive 18 times the sine of 3x, which is going to make 0 with this. Unfortunately, the middle term, negative 60 times the cosine of 3x, is not going to be 0. So number 1 is not going to be true for the solution. So let's try number 2, or the second function. All right, so do a little. All right, here we go. So y prime is going to be 5e to the x. Y double prime for the second one is going to also be 5e to the power of x. Okay, so now plugging in, I have 5e to the power of x minus 10 times the y prime, which is the same, 5e to the x, and then plus 9 times my original function, which is 5 times e to the x. Now, all of that needs to make 0. So that's 5e to the x. That's going to be minus 50 e to the power of x plus 45 e to the power of x. And if you notice, they're all like terms here. So 5 minus 50 is negative 45. Negative 45 plus 45 gives you 0. So 0 times e to the x is going to be 0. All right, so 2 works. So it could be B and it could be D. But we got to check on Roman numeral 3. All right, so this one for my single prime, if C is a constant, you can make C a constant if you want. I'm just going to keep it along for the ride because you'll notice we'll get up like terms again. But I have C times E, or I should say, e to the 9x. Derivative of 9x is 9, so 9c. And then for double prime, I write e to the 9x, and then derivative of 9x is 9 times 9c is 81c. All right, so now we plug it in to the original differential equation, which they want double prime, so 81c times e to the 9x minus 10 times 9 c times e to the 9x power, and then finally plus 9 times my original function, which is c times e to the 9x power. All of that should be 0. Let's zoom in. All right, so that's going to be, copy this down, 81c times e to the 9x power. That's minus 90 times c times e to the 9x power plus 9c times e to the 9x power. All right, so 81c minus 90c is negative 9c. Negative 9c plus 9c gives you that 0. All right, so 3 also works. So the answer is going to be D. Let's do number 4. All right, so the next 5 of these, 4, 5, 6, 7, 8, are going to be kind of variations on this. A lot less work to do, a lot more reading and understanding the question. But I just want to let you know we're changing it up just a little bit for these last 5 for this first part. Okay, so we've got a rumor that spreads among a population of people, which is labeled letter N, at a rate proportional to the product of the number of people who have heard the rumor and the number of people who have not heard the rumor. So I see the word product. All right, so the product of the number of people who have heard the rumor, which they're saying P denotes the letter for the letter, the number of people that have heard it, and then times if all my population is N, so N minus P will be the people who haven't heard it, and that's going to be equal to a rate. All right, and the rate it tells me is the situation with respect to time. All right, and for my letter that I'm using above dt, right, with respect to time, that's going to be the rate of the number of people who have heard it, which is letter P. So I'm looking for this in my answer choices. All right, and I'm sorry, I should have mentioned that I am going to have a constant here, all right, where K is a constant. So now if I look at that, I'll find my answer, which is B. Let's do number 5. All right, we've got a rectangle. All right, if you want to draw it, you can, with length x, width y, and area A, capital A. Instantaneous rate of change of the area. So the moment that I read that, instantaneous rate of change of the area, all right, erase that and just go to the first part. All right, when I'm looking at this, right, I'm thinking about then doing this dA, right, because that's saying instantaneous rate of change of the area. But I need to find with respect to the width, and the letter for width is y, so I put dA over dy. So I'm crossing out all of these so far. You notice I actually have my answer already, but let's finish it. It's equal to the sum of the length, so the x, and twice the width, so plus 2 times y. So that's why answer choice D is correct for number 5. Let's go to 6. 3 more on this part. Number 6. All right, so we got a population of a certain species of insect is given by the differential function P, where P of t is the number of insects in the population at a time t measured in days. When the environmental conditions are right, the population increases with respect to time at a rate that is directly proportional to the population. So essentially, I'm looking at this first. So dp over dt, so it's not A, right? And we need some rate, and it's directly proportional to the population, all right? So now I'm looking at it being either C or D, all right? And we're looking at the August 15th, the conditions were favorable and the population started increasing. Then 5 days later, there was an estimated 10 million insects, and the population was increasing at a rate of 2 million insects per day. And to find this constant k, whether it's 5 or 1/5, what we do is we take the fact that there were an estimated 10 million insects 5 days later. All right, so when we're looking at this, we have our 10 million insects or 5 days later, and we're talking about the rate was 2 million insects per day. So if we do that, 2 divided by 10 is going to give us that 1/5. All right, so that's why 6 is C. Let's do 7. All right, so we have a pressure P applied to a gas is increased while the gas is held at a constant temperature, then the volume V of the gas will decrease. So that is what we call an inverse relationship there. And the rate of change of the volume of gas, so with respect to the pressure, so dV over dP, is proportional to the reciprocal, so 1 over the reciprocal of the square of the pressure, so pressure squared. All right, and I know I'm going to have a K up there, so 1 times K, so not A and not D. All right, so it looks like it's B or C, which makes sense, but then it's saying where K is a positive constant or where K is a negative constant. And really it comes down to that first sentence where it says if your pressure P is applied to a gas is increased, while the gas is held at a constant temperature, then the volume of the gas will decrease. So as one goes up, the other goes down. So K, as I said, because that's an inverse relationship, K needs to be a negative constant there. So 7 is C. All right, last one for this section here, part 1. All right, so jogger running along a straight track. They give us the jogger's position function, right, P of T. And it says during the first minute of the run, the jogger's acceleration. Now, if you remember from many, many months ago, we have position, and then the first derivative is going to be the velocity, and then the second derivative is the acceleration. So when I'm looking at these answer choices here, I'm thinking that I should have dP, right, the second derivative with respect to time. All right, so that rules out A and B. And that's equal to the square root of the time since the start of the run. So square root of T, we have K in front. So A8 is going to be C. All right, go ahead and check back. If you need to take a pause, that's fine, but go ahead and continue watching for the next section.